live. All right. Let me just go ahead and share my screen. Welcome to everybody for our demo day, which is on the detection of hate speech in the Tamil language with partnership with DreamSpace Academy and the NYU Center on International Cooperation. This project was going on for the past 2.5 months, led by a team of about 20 to 30 collaborators who successfully completed this challenge. I would like to introduce our speakers for today. Our speakers are from Omdena, Guneet, Isaac, and Ramya. They have played a crucial role in the completion of the challenge and preparing the deliverables, and will also be sharing the details on how we started the challenge and what were the limitations, and also a quick demo. I will probably also give it to Branka, who will give a short brief introduction on NYU, and then we can start the demo formally.
Thank you, Harini. It's a great pleasure to be here. Welcome, everybody. Good morning, or good afternoon, or evening, wherever you're joining us from. I'm Branka Panic, and I'm a visiting scholar at New York University Center on International Cooperation. And we were one of the partners and initiators of the project we will be presenting today. We are a nonprofit research center that is based at New York University with this vision to advance the effective multilateral action for the crisis prevention, for building peace, justice, and inclusion. And we work with different actors from different sectors, with governments, international organizations, with wider policy community. In this case, this was a great opportunity to actually cooperate with civil society ground level expert organization like DreamSpace Academy and data science experts from Omdena to try together to advance peace, justice, and inclusion. So we initiated, just a little bit of a background how this project actually started, as Harini mentioned, 2.5 months ago. We actually initiated this project together with Omdena and DreamSpace Academy as part of our broader capacity building program in the framework of Data for Peace Building and Prevention program, or what we call shorter Data for Peace. And I see many familiar faces in the audience now who are part of this ecosystem that we have been building for the previous several years. And this program seeks to bring together this multi-stakeholder coalition within the peace and prevention fields to build a community of practice that is using data-driven innovations to drive greater impact. So we started this journey actually in September last year when we organized Discovery Day, and some of you were also part of this cooperation with our partner DataKind, where 10 peace-building organizations were having consultations with data scientists to explore possibilities of advancing their mission and goals with data science potentially. So DreamSpace Academy entered the next phase of this capacity building initiative with Omdena, working on developing a model for automated hate speech detection for Tamil language in Sri Lanka, as Harini mentioned. And I do want to reiterate this and to mention that there were 4 people who are presenting today to whom we owe a great gratitude for their participation and efforts. They were crucial parts of this AI challenge. So you will hear from Ramya, Isaac, Guneet, and Govardhanan, with many others actually who were part of this 10-week journey: Sarita, Philip, Pradita, Arjun, Hardik, just to mention some of them, and hopefully they're also joining this call and can join discussion afterwards. And Of course, the team, the leadership of the DreamSpace Academy team on the ground. I mentioned Govardhanan, but also I would like to mention Gunnar and Kishot, who were there supporting the team, and all this under the careful leadership of Omdena team. So big thank you to Harini and Rishabh, who were guiding us through this interesting process. So we owe you a huge thank you. And with this, I actually want to give the majority of the time of this event to actual project presentation. So I will immediately pass it first to DreamSpace Academy and then to Omdena to show us actually what we were been working for in the previous 10 weeks. Thank you, everybody, and I look forward to the presentation.
Thank you very much, Priyanka. Right now, I can pass it on to Govardhanan to represent the DreamSpace Academy.
Greetings, everyone, and I'm really sorry about my inability to turn on my cam due to unstable weather here. So I'm the project representative from DreamSpace. I represent my organization, and DreamSpace is an organization that that was set out to solve problems that rooted out from 3 decades long civil war. And we believed, and our researchers told us that most of the impedances to the country's development and most of the violence sprouted from communal hate and like really deep hates that were born from the war. So we launched a project, the project ISLE, approximately 2 years ago, that which is that sole intention was to root out these deep communal hates and devise ways, mainly using artificial intelligence, to remove them and bring prosperity between societies. So as a step forward in our in such efforts, we had collaborated with NYU CIC and Omdena and decided to develop this artificial intelligence system that segregates hate speech from non-hate speech. And yeah, here we are. And I'd really like to thank all the contributors who worked really hard for this, especially Isaac, Guneet, Ramya, and Philip, who I believe isn't here. And I also thank Harani and Rishabh from Omdena for like for making this contribution possible, and Branca from NYU CIC as well. With this, I hand over the chance to Harani. Thank you, everyone.
Thank you, Govardhanan. If we have now, we'll begin the demo day on the presentation where we will have the Omdena collaborators talk about data collection and different parts of the pipeline in a technical and a non-technical manner. Meanwhile, if anybody has questions, please feel free to share it in the chat window and we can address them later or in the Omdena LinkedIn chat as well. So I'll let our collaborators take it up from here and they can start sharing the screen.
Thanks everyone. So just give me a minute, I'll start and share my screen. Hello?
Yeah, Guneet, we're able to.
Yeah, I'm having some trouble. Just give me a minute. I don't know, my mic got blocked. Just share my full screen. Is it visible now? And can you all hear me as well?
Yeah.
Okay. Yeah. So hi everyone. Thanks for the introduction from Harini, Govardhanan, and Branka. And I'd like to thank everyone, my fellow collaborators as well, for like making this project a possibility. And Not wasting too much time, we're going to go into the technicalities now specifically. And in between, if you're not able to hear me, like please put in a message in the chat box so that I'll be sure that there's some error from my side. Otherwise, yeah, I'll just begin. So basically what this project was and what was the outline of this project. So let's start with that. So first of all, the project focused upon like coming up with like a kind of an AI tool which could identify hate speech in a given sentence or any text format as such. So our aim was to actually solve it for the Tamil language, specifically for the Sri Lankan region, because there's a little difference between the kind of dialect with the Indian and the Sri Lankan Tamils that is spoken. But our aim was to actually create a kind of a framework which could later be extended for other languages as well. And because it's actually once you build a kind of a framework, it's easier to adapt it for the other languages. So basically, that was our aim, to build up a perfect framework from our side. So we took around 2 months, and our team actually was able to successfully leverage upon the existing knowledge in the domain of hate speech, which is quite a common now topic in the past 3-4 years in the NLP community. People are taking up this hate speech as a serious challenge, and they're trying to come up with various techniques to solve it. So it also helped us in giving out a significant good results from our side. So we used to just generally like lay it down for everyone. We used the power of language modeling, which are the recent natural language processing models, to power an API which could segregate sentences into positive or negative hate speech. So positive means it's a hate speech, or negative means that it's not a hate speech, to simply put in front of you all. Going to the next slide. So what were the objectives? So basically that was the outline that we saw, how we broke it down among ourselves. Now it was a big team that we had, so we had to break down the project into smaller pieces, and every small team was actually solving these small challenges, and we all came together, bundled all the findings from each and every objective, and we were able to give what we'll be showing you by the end of this demonstration. So first of all, we began with like compiling sources of label data for Tamil hate speech. Whatever, anything is there, any literature, any data set which is available, which has catered to this problem previously. So for that is the first aim, like the first strategy, to collect anything that is available. Then to analyze, is it enough or do we need to manually annotate it? But in our case, we had to go for the manual annotation so that we could find the right kind of data suiting our problem. Because we had to, again, as I said, we had to take care of this fact as well, that there is a little dialect difference, not a major one, but a small dialect difference between the Sri Lankan language as well as
That's the problem.
yeah.
I registered. I mean, there must be hundreds of people who registered.
Sorry.
Yeah, no. So that was like construct. So we that aim was to construct a manually annotated data set to increase the amount of label data for modeling. So again, like from the collecting the sources, we went to the manual annotation. We our team did a great job, and because this annotation was dependent on Tamil speakers specifically, it was a really good job for them to actually work so hard and give us a right amount of data, which we could use for the modeling purposes. The next objective was a very obvious one, that whatever data we were able to collect, we actually passed them through pre-trained models. Pre-trained models being this a concept of transfer learning we used. Actually, we tried to leverage upon the existing languages models which were trained upon Tamil language, not for Tamil for hate speech specifically, but for any Tamil task. And we actually fine-tuned them. That is, retrain them on our own data, and we actually were able to perform the analysis. We did some rigorous testing on the top performing model that we were able to find, and then we made it a part of the API to complete the whole pipeline. We also did hyperparameter tuning, which is most important one. Once you have a model selected, you do a lot of tuning, just try to like make it more sharp, intelligent enough to handle the problem. And the final one is like to curate the process of training the form of a pipeline. So we wanted it to be a form of a pipeline so that later on, if people run it, it's easier for them to like to adapt, like for DreamSpace and NYU team, to adapt to the models we implemented and make some changes later on their part as well. So to make it all very simple for them as well. So that was like a major objective and the outline of the project. Now we're going to, so this is like before we go into the sub segments. This was like a kind of a pipeline on the whole project altogether. So just giving you a kind of an overview of what happened, a very simple overview. There's a lot of details that are hidden, but yeah, it's like a complete, you do the data collection and the pre-processing, you combine it with model experimentation on a tool called DAGSUB, which is very good for like managing pipelines and solving your challenges, specifically ML workflow challenges. And then we actually deployed it using Docker and Fast API. So a very simple looking chain, but yeah, a lot of complexities behind it. Moving forward, let's go one by one. So first, we're going to start with data acquisition. What was data acquisition? So basically, again, as we had discussed earlier, it was basically scraping the data related to hate speech from a variety of sources. Now, here we had to identify the resource, what kind of sources we could find this kind of language: YouTube videos, Twitter tweets, Facebook postings. So these were like the major areas from which we actually scraped. So we wrote a Python code, and because there are a lot of open source libraries that are available to scrape data from these specific sources, use them, and we were able to obtain a large segment of data. Now, it's very important to note that whatever data we were scraping, it's not like everything was relevant for a problem, because we had to avoid some junk data as well, because not everything is a hate speech, right? So it was very important to identify what kind of language, what kind of text we were collecting, what exactly was hate speech. Are we defining the hate speech in a right way? And is it solving the problem in the downstream task that we are looking for? So that was a big challenge as well in the data acquisition. So this is like the kind of analysis which was really relevant, and a lot of thought were put into this particular thing. Now the data annotation pipeline. You have acquired the data, what to do? Now, again, as I was talking about, now we talk about this challenge: how to identify something is if something belongs to positive or a negative hate speech. So basically, the Tamil language speakers used tools to actually annotate the data that is called Docano, and they did that for like they manually annotated around more than 1,500 data instances, and they segregated it into two classes, which was, like as I said, positive and negative. So there are a lot of involvement in other kind of hate speeches as well. Like there are a lot of categories of hate speech as well, but our team focused just on the broad categorization, and we did not go into the depths of each hate speech distribution as well, because that is something which is like a future work, because we first wanted to establish a kind of a good framework, and a framework which could actually solve the initial challenges and the initial aim and the vision we were focusing upon. So we did use this open source tool Docano, and we did the annotation, and we were able to get around more than 1,500 data points, which we annually annotated, and we were able to collect some 2,200 data points from the like available sources online. So basically that was like the data annotation. So again, like talking about the challenges and the conclusion of this. Distinct challenges were like for like speakers to identify like hate speech and free speech. It's really difficult because there are a lot of intricacies involved in like one word as well. So for example, there might be a single word which might not be a hate speech for someone, but might be hate speech for someone else. So there are a lot of context involved. So there's a criteria you need to identify. So as I was highlighting, whenever we are annotating our own data, manually creating our own data, there's a lot of challenges as to normalize how we are going to, or standardize among ourselves, like how we're going to label something as hate speech or not hate speech. What are the points which you actually consider while calling something as a hate speech? So these were really important. And the to market data as hate speech rule agreed upon. So what we agreed upon was we define hate speech as language that can incite others to discriminate or act against individual. So basically, ethnic, religious, racial, gender, or national identity, and like whatever which is derogatory in any sense is kind of like the hate speech. So keeping it very simple to the definition, not going to the complexity of the linguistics, but yeah, still trying to stick to the real definition of hate speech. So we actually, so the second challenge was availability of actually of the people who are actually familiar with the language. So we had people from all different countries, different regions, and many of them were not Tamil speakers. So this was a big challenge in its own, like that we needed Tamil speakers who could annotate this particular data. So it was a very challenging thing, but again, as I said, it was a commendable job done by our collaborators who were Tamil speakers, and who did really hard job in actually annotating a data which was more than 1,500 instances, which is difficult when you are actually selecting data, then trying to find the good data actually, which is suitable for the model as well. So it was a big challenge that was solved. So again, like 1,713 records to be precise, who annotated 413 positive hate speech and 1300 negative hate speech. So it was an imbalance, but still like a very well done job by our team. Now to move forward to the modeling part, I'll hand over the stage to Isaac, who did a really great job in solving this hate speech detector model, and he's going to discuss about the natural language processing transformer model specifically, and also about how the inferences and the analysis was done. Thank you. And yeah, Isaac,
Okay.
it's
Okay, can you hear me?
yeah, Isaac.
Okay, thanks. You can see the slides, right?
Yes, Isaac.
Okay, thanks. So hello everyone. So yeah, after we had the tagged for annotated the data set, we started the modeling process. And as Gunit already described, we focused on the general task of binary classification on Tamil language. So this means that we have two classes, the positive and the negative. Positive means that the text includes some kind of hate speech discourse, and negative that it's not related to hate speech discourse in the text. And we also had as an objective to focus on recall to try to increase the recall of the model on the positive class. And well, we had some data annotated in Docano, as Gunit explained, but we were able to also collect other data from other. Yeah.
What about things like
yeah, I'm putting it on their admin in the hardcore document.
Okay.
Yeah, sorry.
Yeah, don't worry. Yeah, and well, in total, besides from Docano, we were able to extract data from other sources. Govardhan also provided a good amount of data. So in total for training, we ended up with around 3,000 observations. And for the positives, and around 1,700 positive examples. And well, in order to approach this problem, well, we first had some challenges. So I'm going to describe them, and then how we approached or overcame these challenges. One of them is that, as we already said as well, it's a low resource language in the sense that there's not a lot of data and trained models and in general AI resources for other languages that are mainly not English, for example. Another characteristic that was a challenge is that there's a phenomenon called like code switching, where texts combine different types of scripts. For example, you could find text with Tamil script combined with Latin and maybe some English words. So this was also a challenge. And well, we had an unbalanced data set, meaning that there are more negative samples than positive. So this makes it a little bit more difficult to have a good recall, because it's all about detecting the positive examples. So in order to approach this, we focused on using or exploiting transfer learning. It's a very general framework. So specifically, we use transfer learning by using a pre-trained transformer, which is a large language model which is pre-trained on label text. In this case, we found very useful this model, this transformer model trained by Google. It's called Muriel. And the most relevant thing about this model is that it was trained on 17 Indian languages. And it also included the code switching text characteristic, and it included the Tamil language. So it was, I think this was very, very useful, because this means that the model already knows some of the structure of the Tamil language. And yeah, we try to explore some hyperparameter tuning using a weighted loss and playing with the probability that the model outputs to consider something as hate speech or not. But besides that, we didn't have much time to play with other hyperparameters like learning rate or other parameters. And well, given all of this, we also had a separate test set that we didn't use for training, neither for evaluating the model. So this was just like at the end of everything, once we had chosen the best model we could find, we tested the model on this other data set. And this one, as you can see, it's a little bit more balanced. We have like 76% of negatives and only 24% of positive examples. And we decided this because this resembled more the type of distribution that we were finding in real world data. So this could be a more accurate approximation of how the model would perform in a production setting. And we reported several metrics like F1 score, precision, and recall, given that recall was one of the objectives to improve. And well, we also reported accuracy for an overall performance metric. And we can see, if we focus on the positive class, we can see that we were able to squeeze some performance improvement in recall up to 87%. Obviously, this has had an impact in the precision of the model, meaning that the model might make some mistakes when predicting something that is not hate speech as if it was hate speech. But having a very good recall or a good coverage on the positive class. Of course, if we look at the overall metrics, there's still a lot of improvement a lot of room for improvement. So yeah, that's something that could be iterated on. And yeah, just to as Gunit said, we used several technologies in order to achieve this. One of them was DAXHub, which is kind of like a repository for managing data versioning as well as code versioning in order to collaborate with other members of the team. DBC is the one for data versioning. We use Hugging Face library and PyTorch for training models. And it was very useful to use Google Colab notebooks, given that they provide free GPU resources in order to train these kind of models. And something nice about this DAXHub is that it provides like a pipeline or a graph where you can visualize the different steps for training a model. So we can see here that we start from data, from the training data. Well, we have the two splits, the training and the test data set. For the training data set, we take that as an input, train a model, and then we generate different model artifacts. The main artifacts are the train model itself and the arguments that we use to train it. And then once we pick the train model, we can take our test data set and generate the metrics in order to check how the model will perform in a production environment. And well, now Ramya will explain a little bit about an extra testing that we made in order to better understand the model performance beyond accuracy or F1 score. So thanks.
Yeah, thanks, Isaac. Yeah, moving forward, in this particular project, we did one behavioral testing. So it is it's like a black box testing that is concerned with testing the different capabilities of a system by validating the input-output behavior. That is, it is beyond the whatever the precision, recall, accuracy. We are testing the behavior of the model. So here we actually took this concept from this particular beyond accuracy behavioral testing of NLP models with checklist, this particular journal. And the main objective of this activity is to give some indication on how to proceed for the further training on what kind of samples that can be annotated to improve the model performance. So here we considered 3 different categories in this behavioral testing. One is minimum functionality test. In this particular testing, we have some simple test cases to check the behavior within a particular capability. Like the first one we took is for the neutral inputs, and the second one is for the different kind of inputs for the same test data, like one in complete Tamil and the other in Tamil Latin, and then that is writing Tamil and English, and then Tanglish, like mix up of it's called code mixed, like mix up of Tamil and English texts. And the second kind of test which we did is like invariance test. This is to check if the output of the model doesn't change, if there are any changes in the words like typo, and if we change any name, particular person's name or the place name, such kind of test comes under the invariance test. And the third thing is like directional expectation test. Here mainly what we did is like we considered several adversarial inputs. Those are that contain the hate speech related topics, but those are not hate speech actually. So we took such kind of inputs and we tested the model. Moving on to the pipeline, like we have come up with the various test case in the separate CSV files, and we used a script to run it and to get the result in the JSON form. And here actually we tested upon the best model from the previous modeling task as described by Isaac. Yeah. So these are the results from the behavioral testing. Like as I said, for the neutral inputs, like we could find out of the 22 which we took in the final iteration, like the 17, like 77% were failed, and if you see for the same kind of input, for the same that is representing in 3 different forms: Tamil, Latin, and Tanglish. So if you see, like we could see a good performance over there, but in Tamil Latin, it is like we need to improve upon. And then if you see the adversarial, it is to 81%. You can even go through the examples over here, like for example, இரு வாரங்களில் வெகுவாக மோசமடைய போகும் இலங்கை. So this is considered as hate speech. So the example which was given here is like those are the failed ones, like that should be the other way around. And if you consider the typos, most of the typos which we consider were passed through the model, and the one thing which failed is the one displayed over here. And we actually verified upon the failed test cases, and we came up with some observations mainly for the neutral test case failures. The one main observation is the test cases with the Sri Lankan political leaders' names and political and Sri Lankan places like Mullivaikal and some specific days later words like Vesak, which was used in Sri Lanka, was marked as positive, and we even verified by changing those names with other words, and it was accepted. So these are This is one important finding, and the next one is some suspicious activities like a walking demonstration. It was marked as positives with just the word used, even though the input was a neutral input has a neutral context. It is still marked as a hate speech. So we just tested using a different word. So instead of Nadai Bhavani, we used Sale Pani. In those scenarios, it was not marked as a hate speech. So similarly, we could find several. These are the main observations from the neutral test case failures. Yeah. So moving on to the model deployment and model demo, like Gunit, you can go ahead. Yeah.
Sure. Thanks, Ramya, for the discussion on the behavioral testing. And yeah, I'll go one by one over it. So first, I'll just share my screen. Can you confirm if you can see my screen? Share the whole screen.
Yeah.
Can you see my screen?
Yes.
Yeah.
So, basically, we have a project right now. So it's in a raw form because it's locally hosted as of now. So we basically have a Docker container, which I have run here. By simply, I have the repo. I went to a particular folder named backend, and there I've run the Docker file by Docker compose. So that's like a Docker compose up is a simple command line I used, and my Docker, it ran my Docker container, and now the project is ready to go. So this is like a setup. First step is the setup. Now I'll go to the implementation of it. So if you see closely, here I have this fast API doc actually where the application is hosted. So now I can actually see how the API is being used. Currently, it's not. We don't have the connection set up with the existing tool of DreamSpace, but this is like the mind which is working right now. I'm going to show you a live demo about it, so how the model is working. So I already have selected two examples. One is like totally not a non-hate speech, and the other one is a hate speech. So I'll go to Google Translate, and if you can see, I love everything in this world. So it's a very positive comment that I have, and I'm going to test it here. So I just pasted a text, and it's executing actually now, and we'll soon get the result, and we can now like even if we have to keep in mind that the model accuracy is quite low, like it's still around 51.5%, but still when we test it upon various test cases, it's working well. Like it's a sample demo that we have with confidence of 61%. It said that it's non-hate speech. Now I'll go to another sentence, which is no matter what you do, you can't do anything. So this is like a negative sentence. This is not a pure hate speech, but it's a negative sentence that we have here. So if I test this one, I just need to paste it here and here. Let's see. You can all see my screen, right? Just to confirm.
Yeah.
Okay. Thanks. So yeah, with the 73% of confidence, it said that it's a hate speech. Now, this actually demonstrates the kind of the understanding our model has, because that even though it's a 51.5% accuracy, it's still able to detect the hateful kind of sense in the sentence. So again, as we'll increase more data into it, which is actually a limitation, we're going to discuss about it coming soon. But as the more data we add in, the more robustness this model would get. Right now, this just demonstrates the kind of power it has, as well as where it might not be very accurate enough. But its precision for hate speech, like detecting the any kind of hate speech senses, still recall is very high, as Isaac had highlighted. So you can see it here actually. So going back to the presentation, I'll just go. Yeah. So we saw the live demo. We are just going to discuss about the limitation and challenges. So any question related to the demo, you can we can keep it at the end, but we'll start with this limitation and challenges phase. So biggest challenge, volume of the label data. We don't have like a large amount of data. We can call enough to like have a model which is handling real life scenarios where you have like tons of different kind of languages being used. So the robustness that we want, the generalization over the kind of hate speech environment we are talking about for this model, it's still a big challenge because it depends on the kind of volume of data the going into it. So the more training we do with better balance, right now the data is also in balance, which we try to handle through focal loss, but still the more we go into the depths of it, the more data we'll be able to get a better and a better model with higher accuracy, higher ROC score, higher recall as well, which is our main focus. So familiarity with the Tamil language, why this was a big challenge is because when you're performing error analysis and designing this behavioral testing, you need people who are native speaker of the language, right? So this just cuts down the volume of people who can directly get involved into this particular task. So this was again a challenge for us as well because we did not have many speakers who could handle this two subtasks. So it's again an important thing. The more people you have from the native language, the better it would be. So lack of robust pre-trained models. With the kind of pre-trained models, like Isaac did discuss about it in his language modeling part, that we use Mural performs the best, but still, if you're talking about a model which is dedicated to a particular task, we'll still need some kind of proper pre-training, what we call, or like fine-tuning, I should say. Not pre-training, fine-tuning is required. So again, this is again dependent upon the kind of data you're going to feed in, and again, this is like a back and forth kind of a cycle. Like there's no answer to it. It's actually dependent on the data. The more better the data, the more robust the data, the better we can make the model perform over it. As well as like having more models which are pre-trained over large amount of Tamil data only, like pure Tamil language, that can also like help us in having better weights, which can actually be like extended using transfer learning to this particular problem. And familiarity with the chosen tools. It's more about the more so this is exactly not a challenge or limitation, but rather like the more like there's less number of people who will be familiar with the all the libraries, all the for example instances of DAGSUB, DVC, or like Hugging Face. So the more people are familiar with this setup, this pipeline setup, many people are not right now very much familiar with the workflow, ML workflow environment. So, and we used it very much in our project. So this is again like a kind of a challenge from moving from just the standard collab notebooks or your Jupyter notebooks to actually forming pipelines, handling, managing persistent volume, and doing some Docker stuff, the cloud stuff, the MLOps. So it's a kind of a challenge for anyone. So for conclusion and future consideration, like Isaac, you can just take the charge.
Yeah, thanks.
I'll just keep the share. Okay.
Thanks. Yes, so to wrap up the presentation, I would like to make some comments on the conclusions and future considerations for the project. So yeah, I think we were able to, I mean, as Vinit explained, we were able to scrape a large amount of data, but in the end, given the few amount of collaborators that we had familiar with Tamil language, we were able to only label a smaller amount, around 5,000 observations between the ones that we annotated and other data that we were able to collect from open source on the internet. Yeah, we could leverage DAGSUB platform, which definitely made it very easy to collaborate with other people in the team and also in terms of reproducibility of the experiments. I think it's important to start using this kind of tools, even if there's some learning curve. I think if we cannot leverage this kind of tools like MLOps tools, it becomes very difficult to, for example, trace where the data is coming from and try to being able to reproduce the experiments. So I think this was a good good starting point. Something interesting was the behavioral testing that we explored during the challenge, because it will allow us to understand the model in different ways besides the standard accuracy or F1 score. I think exploiting the transfer learning using these large language models will be very important. We saw that there's a lot of room for improvement in modeling, but I think it's a good starting point because this kind of architectures is very general. It can be used for a lot of different NLP tasks, and it will allow the DreamSpace team to then replicate these experiments with other languages, or maybe make a more granular classification. Maybe if they want to classify not just into hate speech or non-hate speech, but also classifying different types of hate speech, like in politics or religion, or more specific, this same approach can be used and exploited. Some considerations for future iterations. As I said, these type of methodologies of using pre-trained language models to fine-tune on label data will be very important to have a better performance. As Gunit also said, performing error analysis, we didn't have a lot of members that were familiar with Tamil language, but it will be important to identify which were the examples that the model got wrong, and what were the characteristics that they have in common, in order to guide future data gathering based on this error analysis and on the findings that we can get in order to improve the model with more annotated data, and also play and explore the classification threshold. As I explained in the modeling part, there's a trade-off between recall and precision that should be considered. So yeah, I think that's it from my side. Thanks, and I give the word to Harini.
Yeah. Thank you very much, Isaac, Gunit, and Ramya. On the behalf of the entire team of collaborators and Omdena, I would like to thank all these collaborators who participated. We had a total of about 30 collaborators from 13 countries. Thank you for their hard work over the past few days, because of which we arrived here. And given that we only have a few minutes left, I'll just take this chance to address one of the questions in the chat window. Gurit, Ramya, or Isaac, would any of you would like to address the question by Abdul regarding the data imbalance?
So, yeah, like I can address. So we had used the focal loss specifically because it's actually used for imbalance as well, like handle the imbalance. So that was like a loss function we went for. And Isaac, if you would like to add in onto something else about it, but majorly that was like one of the main metric, like the loss function changing.
Yeah, I think it was, I agree with you, it was mainly playing with the loss function in order to penalize the model more on mistakes that it made from the positive class. There's another technique called data augmentation that could be used, but given the limitations of time, we couldn't explore these other type of techniques, but something more straightforward, like penalizing the loss function to train the model. Yeah.
Thank you, Isaac. We also, collaborators, the participants also want to know, how did we actually do the manual tagging? And I think this is a very good question, given that it's in a different language.
Yeah, Ramya, would you like to answer that one? Like,
yeah, I can take it up. Yeah, we have nearly 5 to 6 people, Tamil speakers, and we have a few people from the DreamSpace end. They are from Sri Lanka, so they also helped us from doing this manual tagging, and we used a tool called Docano, which helped us to organize the activity, and we also have a review tag because few of us are from other regions, and our level of knowledge to the Sri Lankan context is different. So if you have any doubts, like, we will mark it as review, and team from the DreamSpace will help us to identify and mark it correctly. So this is how we carried out this activity.
Thank you, Ramya.
Could I ask? I have few points to say here. I'm sorry.
Yeah, please go ahead.
First of all, congratulations to the team. They done a great job in doing the work that they have brought out here. A question to Ramya. Ramya, since I'm a native speaker as well, I'm not the Sri Lankan Tamil, but the proper Indian Tamil basically. If my understanding is right, there are a lot of colloquial usages which actually differ from the actual classical language, where some of them are used as, even the proper usages are used as an euphemism, or probably an indirect way of stating some other thing, but the literal translation means something different. And it could also be a case where the very same statement could be used in a very true sense or in a sarcastic sense. So I suppose you could try something in the future for taking this into consideration as well.
Yeah, sure. Thanks for your feedback, Shankar. That is why we consider this behavioral testing, and we even consider several adversarial inputs for testing. Maybe we recommend a DreamSpace team to come up with more data in certain areas, so that it will be easy to train the model in that scope. Yeah.
And one other clarification that I would love to say here is the sense of hate did not start with the Civil War. Rather, the seeds were sown probably a lot earlier against the Tamils. It started pre-independence, and the Civil War was rather a culmination, of that particular hate, basically.
Yeah.
Yeah.
Right. Thank you. Great job.
On to the next question about or maybe rather the final question for the session. One of the participants wanted to know about the language complexity the model can deal with. Is it about short phrases or sentences of multiple clauses?
Yeah, the model itself that we use can leverage to process like a whole paragraph. It's a large language model, so it's even trained with long sentences. During the fine-tune, I think it depends on the fine-tuning that you do, that you perform on the distribution of the length of the paragraphs or sentences that you use for fine-tuning. In this case, I don't have right now the metrics or the statistics of the length of the sentences that we use, but it's generally shorter sentences, given that the data comes from social networks like Twitter and Facebook. So it's usually shorter, but the model itself could be fine-tuned with longer sentences or even paragraphs. So, but it depends on the data that you have.
Yeah, I'll just add in. So like the kind of setup we have right now, it can deal up to 512. So that was like the length we had specified in the code. So it can handle up to that 512 tokens. So that is like around 512 words. So that is like a good big large paragraph that it can handle. So yeah, that's like the thing. And as Isaac said, we can it depends on the kind of fine tuning we do and the token length we set up. But that's it.
Thank you, Guneet and Isaac. With this, we come towards the end of the meeting, and a huge thank you to all the collaborators, the NYU team and the DreamSpace team. We hope to collaborate in the future too with a different set of collaborators and the teams. Thank you very much for joining us.
Thank you, everyone.
Thank you.
Yeah.
Thank you, everyone.